Now it's time for us to solve the inverse of a 2 by 2 matrix. Just like this 4 matrices here, A, B, C, and D, we are tasked to solve or to find out their inverses. So in this process, we can use theorem 1.4.5, which uses the concept of a determinant, and that the inverse, I'm going to write it here, the inverse, let's say for A, is equal to 1 over AD minus BC, the determinant, and we simply interchange D, A here, negative B, negative C in this manner, where A is the first entry, B is the second on the same row, C is the first entry of the second row, and D is the last entry. So again, let's start with A. A is 2, B is negative 3, C is equal to 4, and D is equal to 4. So if we have AD minus BC to be placed here later, okay, we'll have 2 times, oh sorry, my bad, this is not D, this is actually 4. 2 times 4 minus negative 3 times 4. I hope I have enough spaces here, but of course you have space at the bottom if we don't have much spaces here at the top. So this is actually 8 plus 12, so that's 20. Your determinant is 20. So you could get the inverse of A with this. The scalar quantity you're going to multiply is 1 over that result of 20 to be multiplied with this assignment. So 4 is already here, 2 is here, so B is the negative of negative 3 becomes positive 3, and C, which is 4, becomes negative C, negative 4. And if we're going to do that, the inverse of A is 4 over 20, or 1/5, negative 1/5 here, 3 over 20, and 1/10 here. So this is the inverse of the first 2 by 2 matrix using theorem 1.4.5. If I'm correct, that's 1.4.5. Next here, so same process. It's AD minus BC. This is D, this is A, negative B, negative C here. But A on matrix B is 3, B is 1, C is 5, and D is 2. So AD minus BC will look like 3 times 2 minus 1 times 5, 1. That's the result. That's 6 minus 5, you have 1. So our result here is just a scalar quantity of 1. So D is here. That's 2. A, which is a 3, is here. Negative of 1, negative of 5. In short, the inverse of B is 2, negative of 5, negative of 1, and then 3. That's how you get the inverse of a 2 by 2 matrix. Let's continue with C. Okay. So for C, again, same formula, AD minus BC times D, A, negative B, negative C here as well. So A here is 2, B is 0, C is 0, D is 3. So AD minus BC, I have 2 times 3 minus 0 times 0, that's 6. This is 1 over 6. D is, earlier was 3, so this is a 3 here. 2, of course, there's no negative of 0, so it's still 0 here as well. So the inverse of C is equal to 3, 6, or 1/2, 0, 0, 2, 6, or 1/3. Right? D and A. That's correct. And finally, for here, same formula. 1 over AD minus BC. Interchange D and A. Negative B, negative C. So A is 6, B is 4, C negative 2, D negative 1. So AD minus BC. 6 times negative 1 minus 4 times negative 2. Negative 6 plus 8. That's positive 2. So we have 1/2 D. So I have here negative 1, 6, negative 4, negative 2, positive 2. So our inverse of D is negative 1/2, negative 2, because that's negative 4 times 1/2. Here, positive 1, positive 3. Alright, so these are the inverses. Okay, the spaces are just enough. These are the inverses of their respective 2 by 2 matrix. And we used here the theorem 1.4.5. Thank you for watching.